For topic 3, we're going to find a rectangular equation for a plane curve defined parametrically. So basically, we're going to have these parametric equations. We're going to convert it back to its just original, like OG rectangular form equation. Okay. So it says here to convert an equation from parametric to wow. To convert an equation from parametric to rectangular, we must remove the parameter. Okay. So we take out that t and we rewrite it just as like one equation, okay? This can be done by solving one equation for t or an expression involving t and then using substitution. So we're going to look at two, we're going to look at three different examples, kind of doing this differently. Not each time, but kind of differently each time, okay? So it says here, graph the plane curve defined by the following parametric equations, okay? So we have x of t equals t minus 3, and then we have y of t equals 2t plus 4, and we are told that, hey, t is only going to be defined from 0 to 2, okay? So what does this all mean for us? Well, it's really not so bad, okay? First thing, let's just sort of see what's happening with this. Let's sort of plot some points, get some direction going here. We're going to do that table of values that we did in the previous examples. So we're going to get t, x of t equals t minus 3, y of t equals 2t plus 4, and then that's going to give us some points on the plane. Okay, so let's just kind of start with what we have, and then we'll look into converting, removing the parameter, if you will. So we know that t is only defined from 0 to 2 inclusive, so let's look at 0, 1, and 2. Those are nice, easy values to work with. Okay, so when t is 0, x of 0 is going to be 0 minus 3, or negative 3. Remember, I'm just doing regular old function notation here. Y of 0 is going to be 2 times t, so 2 times 0, which is 0, plus 4, so 4. So we get a point on the plane, negative 3, 4. Now, for t equals 1, we get x of 1. Whoops, I was about to put a t. We get x of 1. So t is 1, so we get 1 minus 3, which is negative 2. And then y of 1 is going to be 2 times 1, which is 2, plus 4, which is 6. So we get a point on the plane, negative 2, 6, at t equals 1. Now, when t equals 2, we get x of 2 equals, well, t minus 3 is going to be 2 minus 3, so negative 1. And then y of 2 is going to be 2 times t plus 4, so 2 times 2, which is 4, plus 4 is 8, so we get the point on the plane, negative 1, 8. So let's see what that looks like. So we have negative, this should not be negative 4. This should be positive 4. So the point on the plane when t equals 0 is negative 3 comma positive 4. Please change that to positive 4. So negative 3 and then 2, 4. So we get this point. And then we have negative 2, 6. So when t equals 1, we go negative 2, 6. So this is t equals 0. T equals 1, and then we get negative 1, 8. So this is t equals 2, don't put a 3. This is t equals 2. So we can see that with successive values for our parameter, we're definitely doing something like this. Okay, so that's kind of thinking of this just looking at the points from our parametric equations, but we can't necessarily assume this is on a line. We could be doing some wacky stuff here. So let's go ahead and convert this, remove the parameter, and turn this back into just a regular old rectangular equation. And let's verify that we do for sure have something linear. Because again, this looks linear, but we can't definitely say these points are connected with a line until we see that rectangular form of the equation. Okay? So let's go ahead and rewrite this. So we have x of t equals t minus 3, and then we have y of t equals 2t plus 4. Let's rewrite these, but not in function notation. So let's just say, hey, x equals t minus 3, and let's say y equals 2t plus 4. Okay. Now we want to, in this case, solve one of the equations for t. That is one method we have. Once we kind of take these out of that function notation, try to solve one of the equations for t, and then use that value for t, plug it into the other equation, and then you've got something you can work with. So let's go ahead and take x equals t minus 3. Let's solve for t there. I'm choosing this one simply because it's a bit easier to work with. The other one I'd have to subtract a 4 and then divide by 2. Whereas for x equals t minus 3, to get t alone, all I do is add 3 to both sides, and I can say t equals x plus 3. Now I want to take this value for t and plug it into the other equation. So we're going to get y equals 2 times t, which is really x plus 3, plus 4. Okay, so let's see. We're going to distribute the 2. So I get 2 times x is 2x. 2 times 3 is 6. Don't forget your plus 4. So we get y equals 2x plus 10. And this is our rectangular form. We have removed the parameter. So this is rectangular. And more importantly, it's linear. All right, so we can now say officially, hey, this really is linear. So these points that we got, these points on the plane based on t equals 0, t equals 1, t equals 2, we can say they're definitely formed by a line. Now, is this a whole line? Can we say, hey, this line keeps going. It's going to go like this. It's going to go like this. Well, not really. We were limited from t values 0 to 2, okay? So what did that do for us when we think of like domain in rectangular form? We're thinking like x's. So what does this mean for the domain of this? We can't say it's this whole equation because again, if we had this whole equation y equals 2x plus 10, we'd be like, right? So we're not going forever and ever. So we're going to say, hey, this is our equation, but we know when t was equal to 0, x was 3. When t was equal to 2, x was negative 1. So we would say that we can be from negative 3 to negative 1 as far as x is concerned. So that's kind of like our domain restriction here. Okay, so that's it for this one. That is how you remove the parameter. One method for removing the parameter is taking one of the two equations and solving for t, and then using substitution to plug it into the other equation. And then you simplify and you get your regular rectangular equation. It is common to have to look at your domain, see if there's like if your parametric equations were restricted to a particular interval, that you need to be mindful with that when it comes to your rectangular equation. Okay, so in the next video, we're going to look at this example again, but very specifically on a calculator. I want to show you how you can graph parametric equations on the calculator. Okay.